Welcome back. All right, so now let's say we want to integrate something like this. Double integral over d of e to the x squared plus y squared dA, where d is the unit disk, which is the pairs of points x comma y such that x squared plus y squared is less than or equal to 1. Right? How would we integrate that? Well, if you start just setting this up using Cartesian coordinates, you're going to get something like this happening. So let's draw the region of integration here with x and y. Right? So it's the unit disk. So we have this curve, and then we're integrating over the inside there. Right? So keep in mind this curve is x squared plus y squared equals 1, is the boundary of that. Right? So if we set up this integral, what do we get? Well, we have to integrate e to the x squared plus y squared, and let's just say we do dy first, then dx. Right? So what are our bounds going to look like? Well, the top half of this circle comes from y equals square root of 1 minus x squared. The bottom half comes from y equals negative square root 1 minus x squared. All right? So that means we have to integrate from negative square root 1 minus x squared to square root 1 minus x squared. Right? And then the x values come from all the way over here at minus 1 to 1. So we have to integrate this beast. Well, there's already a problem immediately. We can't do the integral of this at all. So regardless of the terrible bounds, we're kind of stuck. Well, we're not actually stuck. See, this region here, it may look terrible in Cartesian coordinates, right, when we set up the bounds, but think of this disk in polar coordinates. The disk, the unit disk, so its pair is r theta. Well, what do we know? We know that r is between 0 and 1, and we know that theta is 0 to 2 pi. Well, it's actually strictly less than 2 pi, but no big deal. But notice the difference here. So here it's described in a very complicated way with an equation on the boundary. Here, it's just a box. Right? So how do we change this integral here over this complicated region to look like an integral over this nice box here? Well, the answer, of course, has been sitting up here the whole time. It's polar coordinates. So do you remember polar coordinates? X equals r cosine theta. Y equals r sine theta. And of course, you should also remember, so this would be like polar to Cartesian. You should also remember how to go the other way, from Cartesian to polar. Right? Well, those equations, you get r squared is x squared plus y squared. In other words, r is the square root of x squared plus y squared. Remember that r is always at least 0. Right? You can interpret negative r values, but usually we think of it as being positive. Right? And then what about theta? Well, if you do y over x, you get y over x is tangent theta, so theta is arctangent y over x. Right? And then, of course, you have to think about what that can mean if, say, x is 0. Right? And you can interpret that. That's going to be something like theta is either pi over 2 or theta is pi over 2 or negative pi over 2. Right? So this is our short little introduction. And in the next video, we'll talk about how to actually start changing these guys.